Hey everyone, and welcome. You know, every single straight line, whether it's on a graph, the side of a building, or a road stretching out ahead, it has a story to tell. And today we're going to learn how to read that story. So what is the story of a straight line? Well, it's a story all about its journey, its steepness, whether it's climbing up or heading down. And the main character in this whole story, the one number that tells us almost everything we need to know, is its slope. At its heart, slope is just a way to measure steepness. I mean, think about it like a hill. A really steep hill, that's got a large slope. A nice, gentle one, a small slope. It's just a single number that tells you exactly how much a line is rising or falling for every single step it takes to the side. All right, so here's our game plan. We're going to start with the basics of what slope even is. Then we'll get our hands dirty and learn how to calculate it. After that, we are going to crack the code on the famous slope-intercept formula, see how it works in the real world, and finish up by looking at a couple of weird special cases. Okay, let's kick things off with the phrase you're going to hear a lot, rise over run. Seriously, this little phrase is the key to pretty much everything else. It just means you take the vertical change, the rise, and divide it by the horizontal change, the run. Slope also tells us which way we're headed. So if you're looking at a graph from left to right and the line is going uphill, like you're climbing a mountain, that's a positive slope. If it's going downhill, like you're skiing, you guessed it, that's a negative slope. It's really that simple. All right, let's get practical. How do we actually put a number on this steepness? This section is all about the toolkit. We're going to learn exactly how to calculate the slope for any line, as long as we know just two little points on it. And this is the magic formula. Now, don't let the letters scare you. That M is just what we use for slope in math. And to find it, all you do is you take the change in the Y values, that's the rise, and divide it by the change in the X values, that's the run. And it breaks down into the same 4 simple steps every time. First, you pick any 2 points on your line. Then you find the rise, find the run, and then just divide. That's it. Let's walk through one together right now. So let's say we have the points 2, 3, and 6, 4. Okay, the rise is the change in Y, so that's 4 minus 3, which is 1. The run is the change in X, so 6 minus 2, which is 4. So our slope, our rise over run, is 1 over 4. And what that really means is this line goes up 1 unit for every 4 units it moves to the right. Okay, so now that we can calculate slope, let's talk about the master key. This is the thing that unlocks the entire story of a line just by looking at its equation. It's called the slope-intercept form, and it's like we're cracking a code that makes reading lines super, super simple. And here it is. Y equals mx plus b. This tiny equation is honestly one of the most powerful tools in all of algebra. If you can remember this and understand what it means, you can instantly read the story of any straight line you come across. And this shows us exactly what each part does. That M is our slope. That's the rate, the action part, the bit that tells us how fast things are changing. And the B, that's the y-intercept. It's the start. It's the initial value. It's where our story begins on that vertical axis. So why do we care about any of this? Because these stories aren't just stuck on graphs, they're literally everywhere. This is where we take that abstract math and connect it to stuff you see every day, from your phone bill to planning a road trip. I love this quote. It's the perfect way to figure out how to turn a real-world problem into a math equation. Anytime you're stuck, just ask yourself this: which value happens just once, and which value happens over and over and over again? The one-time thing, that's your B. The repeating thing, that's your M. Let's try it out with a super simple scenario. You want to sign up for a new streaming service. There's a one-time fee to join and then a monthly cost after that. Can you already spot the start and the rate? Let's break it down. The $10 sign-up fee, that only happens once. That's our starting point, our B. The $5 monthly cost, that happens over and over. That's our rate of change, our M. So the story of your total cost is just Y equals 5x plus 10. See how that works? Okay, so most lines go up or down, but not all of them. Let's finish up by talking about 2 special cases, the perfectly flat line and the perfectly vertical line. These are kind of the edge cases of our story. A horizontal line is totally flat, right? It has no rise at all. Its rise is 0, and 0 divided by any number is just 0, so its slope is 0. Now a vertical line is the opposite. It's all rise, with no run whatsoever. And since we can't divide by zero in math, the universe just won't let us, its steepness is, well, it's off the charts. We call that slope undefined. So let's wrap this all up. Slope is just the rise over run steepness of a line. We can calculate it with that simple formula, and we can read it in the equation y equals mx plus b, where m is the rate and b is the start. This whole thing helps us model the world around us. And of course, don't forget our special cases. Flat lines have zero slope, and vertical lines have an undefined slope. Now that you know how to read them, I promise you're going to start seeing these linear stories absolutely everywhere. In your budget and how long it takes to travel, in business plans, it's always a rate of change and a starting point. So the only question left is, what stories will you go out and find?